Okay, it looks like we're live here, which is good. I'll wait just a second for a few people to join. Hopefully people will remember we have a virtual office hour discussion today. Okay, let's go ahead and get started. Welcome to the optional virtual office hour session for the POSA Concurrency MOOC. What I'm going to do today is talk about a couple of my other solutions to assignment number 3. When I had shown it to you last time, there were a few things that I realized could be improved. And so I have 2 different implementations to talk about today. And of course, I'm also happy to answer any other questions that you might have as well. So let me go ahead and bring up my solution here. We're going to look at 2 different solutions. The first solution that we're going to look at is a variant of the one I showed last time, which is based on the strategy pattern and several other patterns as well. I've reorganized the directory just a little bit to refactor it somewhat so it's a little easier to see where things are. So we have 3 subdirectories or folders here. We have a utilities folder that contains the image utils class that is used to download images and filter images and so on. And we also have the retained fragment manager. No real changes to either of those. We have a directory full of all the activities that we're dealing with. And then we also have a directory that has all the strategies we're dealing with. Let's go ahead and kind of talk this through. I'll go to the main activity first. So I rewrote the documentation at the beginning a little bit just to give a better overview of how this program is actually designed. And what it's basically doing is it's got a main activity which does very, very little except serve as an entry point into the application. And the application itself applies a variant of the so-called microservices architecture pattern. If you Google microservices architecture, you'll find a bunch of discussions about microservices. And basically, this uses intents and other activities besides the main activity to create and invoke these microservices, which are basically small, focused, and highly decoupled objects or components or something. The particular microservices, of course, we're going to use here. We got 4 of them. They prompt the user for a URL to an image, and then they download, filter, and display the image. So those are all the little microservices we've got. And of course, the activities handle runtime configuration changes properly even when they're used with async tasks. And under the hood, we apply a whole pile of gang of 4 patterns. So strategy, factor method, template method, facade, and memento. And of course, the async task framework uses the half sync, half async pattern. So here's what things actually look like here in the main activity. You can see that it extends lifecycle logging activity. It creates something called the image strategy manager, which is really storing the microservices or ways to get to the microservices. I decided not to call them microservices just because I thought that would be confusing since Android has services, and that would be a little bit odd in terms of the nomenclature. But basically, you can think of these things as basically microservices. Here's the onCreate method that gets called when we start. And this method only does one thing other than initialize the superclass. It goes ahead and it calls the doRequest method to initiate the first microservice, which is handled by the strategy manager. And what this, of course, is going to do is it's going to prompt the user. So we'll take a look and see what that does in a second. So it does a doRequest call. Here's the doRequest implementation. As you can see, all it does is it simply forwards to the strategy manager and says, do this request that I just got. Now, as we'll see shortly, when that request is finished, the onActivityResult method gets called back, and onActivityResult turns around and calls doResult, which is basically handling the completion activities of the activity that's just finished. And here's the doResult method. It goes ahead and calls doResult on the strategy manager. So that's basically all the main activity does. Everything else is driven from callbacks. And we'll talk about this in a couple different ways, but that's what I want to show you first. So that's the main activity. Now switch over to the strategies, and we'll go look at the image strategy manager. You can see the image strategy manager defines a bunch of strategies: prompting the user, downloading the image, filtering the image, and displaying the image. Those are the things it knows how to do. And it's got an array of image strategy objects that are as many as there are image strategies to do. Its constructor creates a bunch of strategy instances, one for every different type of strategy. So prompting the user, downloading the image, filtering your image, displaying the image, those are all created as strategy objects and stored in the appropriate location in the M strategies array. And then do request, when do request is called, all it does is it simply indexes into that array with whatever strategy type is being requested here, and it goes ahead and it runs the request that's associated with that strategy type. And we'll take a look at that in a second and see what it does. And there's a couple different variants, one that takes a URI and one that doesn't. And then when things come back, when the operations are finished, the do result method gets called, and that turns around and checks to see whether things succeeded or failed. And if they succeeded, it calls the do result method on the strategy object at that request code. And if something failed, it calls the result canceled, or if result canceled occurred, it calls the do error method on that strategy. So that's basically the basic callback driven model we have here. And as you can see, it's very straightforward. Then each of the different strategies has their own subclass. So everybody inherits from the image strategy class, which is an abstract class. It stores a weak reference to the activity, so it can get access to the operations to invoke new requests and new result handling. It has do request, do result, do error, and make intent, and it stores a weak reference. That's why we made it an abstract class. And then each of the different strategies basically inherits from image strategy. So here is the prompt user strategy method, and you can see it basically calls up to the superclass to stash away the activity. When its do request method is called, that's the first thing that's called. It makes the intent, and then it goes ahead and starts the activity for result, which goes ahead and prompts the user. We'll look at that in a minute. And when it's done, when its do result method gets called back, it turns around and invokes the download image strategy as the result of the prompt user strategy. So it's kind of daisy chaining these things together. If for some reason things go wrong, then we go ahead and find out why things went wrong, and we show a toast. And if the reason that things went wrong was the back button was pressed, then we go ahead and shut down, because that means we're done. Someone didn't want to be part of the main activity anymore, so they bailed out, or they didn't want to be part of the prompt user activity anymore, so it bailed out. And so that's basically what this guy does here, is make intent. It makes the intent that knows how to start the action prompt user. So that's how we prompt things. Let's now go take a look at the activity that corresponds to this. So if we go over to the activities, you'll see the prompt user activity. Prompt user activity inherits from lifecycle logging activity. It has a couple of fields that are set up in its onCreate virtual constructor that will keep track of the text that the user enters if they enter anything. If the user doesn't enter any text, then but instead they press the back button, then in that case this method gets called back, and we set the activity result to basically indicate that the back button was pressed, and that'll cause the callback that's dispatched to realize this, and it'll go ahead and basically exit the activity, which will then make it become a it'll basically take it out of the foreground. Download image, as you can see, this goes ahead and gets the URL that the user typed and makes that the result of the activity. If for some reason something goes wrong, we print out an error message. So a toast comes up saying invalid URL, and then we go ahead and we shut the activity down. So all this guy does, since he's a microservice, is he knows how to do one thing and one thing only. He gets the prompt, he prompts the user, gets the result, and then passes it back as the result of the activity, and then finishes. The get URL method is pretty straightforward. It just goes ahead and gets whatever the URL typed, and we'll put in the default URL if they didn't type anything, and it'll check the URL to see if it's valid if they give a URL or don't give a URL. All right, so that's prompt user activity. That's pretty simple, but notice how straightforward it is. It's a microservice. It doesn't really try to do a whole lot. All its purpose in life is really just to prompt the user. Now, what will happen, of course, after that finishes is the download user strategy do request method will get called. And so the do request method on download user strategy makes an intent to download the image, then goes ahead and starts an activity that will download an image, and we'll talk about that in a second. And when we're done downloading the image, then we go ahead and we do the result if it succeeded, in which case we kick off the filter image strategy, which is yet another microservice. And if things go wrong, then we go ahead and print an error message and bail out. And so that, again, notice, by the way, when an error occurs for anything other than the prompt user strategy, what we do is we go ahead and go back to the prompt user activity. So whenever anything goes wrong in downloading, filtering, or displaying an image, we go back and reprompt the user again. So that's kind of how we get back to the initial starting point of this application. Notice that the main activity has no real screen of its own. It only runs in the onCreate method to spawn the prompt user activity, and otherwise it relies on these callback methods to transition it to the next thing to do. The main activity doesn't know anything else except what it's told, furthering the MicroStrategy philosophy. And here's the factory method that starts the download image activity. If we go over here to download image activity, we will find the following. For the download image activity, this is a generic background activity. We'll take a look at that in a second. It's very simple. All it does is it has an onExecute hook method, and this gets called back in a background thread. And what that does is that goes ahead and downloads the image using the image utils method. And that's what onExecute does. And then there's also a method called onPostExecute, which gets called back in the UI thread after onExecute returns. And what we do here is we basically set the result of the activity to either the path to the image file if download image succeeded, or if things failed, we're going to go ahead and set the result to be result canceled, and then we'll indicate that the download failed. That's a message. That download failed string will get sent back to the main strategy manager, and he'll use that to print out this error message. So we're kind of encapsulating everything very cleanly in the way in which we return results back to the caller. So that's what download image does. Notice that download image only knows how to download images and set results. It's a microservice. And it relies on the strategies portion to do the other things correctly, which it does. After download image runs, and let's assume for sake of argument it runs correctly, then we do the do request method for the filter image strategy will be called, which will go ahead and make the intent to filter an image, start the activity for this thing, and when that completes, then either do result will get called, which will start a request to display an image, or we'll go ahead and get the error method called, which will print out the reason why things failed, and then go ahead and prompt the user again. So you kind of see there's a commonality that's going on here. Now let me show you something else that's interesting about filter image strategy and the download image strategy. Download image activity. Both of these activities inherit, both of these actually all three of these activities, download image, filter image, and display image, all inherit from generic background activity. And this is where the real brains of the concurrency model lurk. So this guy has a progress bar and a text view, and keeps track of the name of this thing. He's the one that interacts with the fragment manager to keep track of all this stuff. Here's the onCreateHook method, which sets everything up. And then the onStart method gets called. I could probably also do this in onResume, by the way, but in the onStart method, we go ahead and we handle any configuration changes, and we'll look at that in a second. We show the progress bar. We go ahead and check to see if there's an async task running or not. If there's no async task, we go ahead and start an async task and execute it. And that's what onStart does. OnStop, when it gets called, it goes ahead and makes the progress bar invisible, so it doesn't block the screen anymore. And when onBackPressed gets called, if you're downloading an image, or you are filtering an image, or you're displaying an image, and you want to bail out, then here's what happens. When onBackPressed gets called, we check to see if we've got an async task. If we do, we go ahead and cancel it, and then null it out so it'll get garbage collected properly. We dismiss the progress bar, and then we set the result of the activity to indicate the back button has been pressed. And that's basically needed because what we need to do when the back button gets pressed is we need to transition back to a point where we're redisplaying the prompt again. And so that's basically how we do that. It's all very clean and microservicey. Handle reconfigurations handles the configuration changes that occur if you rotate the screen, and it does it in a clever way to avoid having to stop the task. You only stop the task if you cancel it by going back, but if you just rotate the screen, the task continues to run. It also tries to check to see if the results have already been computed, and if the results have been computed when the rotation occurs, then you just take the results and return them without doing anything else. And the way you do that is you call the onPostExecuteHook method, which calls up to method that's here. OnPostExecute, for example, will set the result of the activity. And then in this case, in filter image activity and in the download image activity, it returns true. And what true says is go ahead and finish this activity. If onPostExecute returns true, it says I want you to shut yourself down. We're done. And so then that'll return the result, and this activity will go away and pop off the stack. Here's the onExecute and onPostExecute methods. OnExecute is abstract and must be overridden. OnPostExecute is given a default value that returns true, which says shut yourself down. Here's the generic async task, which does a bunch of cool things. It keeps track of the fragment manager and the tag, and its doInBackground hook method basically just goes ahead and calls up to onExecute, which is the hook method, to do whatever you want to do in the background. And then onPostExecute, if it gets called, we'll put the result into the onPostExecute method of the generic activity, the generic async task, which always gets called. It updates the result of the fragment manager and checks to make sure the activity is still around. And if it is still around, it calls the onPostExecuteHook method on the activity. And then if that returns true, it finishes it. And then it goes ahead and nulls out the async task. That's basically what the generic background activity does. Very clean, very reusable. Here is the display image activity. This is the last one in the little pipeline of microservices that get called. And what this guy does, of course, is when his onExecute method gets called, he decodes the image from the path. And that, of course, takes place in the background. That's usually a very fast operation. But if you have a big enough image, it could take a little while to decode. So we run it in a background thread. It's probably overkill most of the time. And then when onPostExecute gets called, what we do here is we turn off the progress bar, display the image, because we're in the UI thread, and then we go ahead and we set the result. Now, there's a couple things to note here. You'll notice that we return false from this method, and that means that we don't actually shut this activity down. And the reason we don't shut the activity down is if we shut the activity down, then any image that had been displayed on the screen would disappear, which of course would completely defeat the purpose of display image activity. So display image activity is going to leave the image on the screen, and then the user will have to manually press the back button to make it go away. And when they do that, that'll of course will go ahead and shut the operation down. So that's where the results will get returned. Okay, so that is basically the set of activities we have going on here. And then the only other stuff we have that's interesting is just the strategies, and we saw the different strategies. Here's display image strategy, which when it's all done, we'll go ahead and transition back to prompting the user for the next run of this application. So those are all the steps involved. I'll take some questions now, and then I want to show you another implementation that I think is even cooler than this one. But first, let's pop back over here, and I'll take some questions. So Will would like me to post the UML. So if you take a look at last week's lesson, I have the URL. I have not the URL, the UML. Posting the UML diagrams. If you take a look at last week's lecture, I have UML diagrams that show this design, the one I just went through. And so you can take a look at that. I actually walked through the design in more detail. This time I walked just through the implementation. But if you go back and watch last week's video, I also went through a slide presentation which showed the design and the patterns that are used in the design and how all the various pieces fit together. And the other question I have is, will the videos be posted on Coursera? Yes, we always post the videos on Coursera. And of course, you can also watch them via YouTube if you want. But the ones on Coursera, I do a little post-processing so they look a little cleaner, and they have a better, nicer looking background, and so on and so forth. Okay, so those were the questions I've got thus far. I'll be happy to take other questions, but I will go ahead and go to the next example right now. Go ahead and switch back over here. All right, so what we just looked at, the code that we just looked at, was the implementation of my assignment 3 that was based on kind of the microservices approach using strategies and other patterns too, but strategy was really the main driver. We're going to take a look at another implementation, and this is one that's even more hot off the press. Some things are exactly the same. The activities part is exactly the same. The utilities part, exactly the same. What's different now is that instead of using the strategy stuff, we use the state pattern. And I take it back. There is one difference over here. Let me start out with this. So if we were to go look at the main activity for this implementation, once again, it's a microservices architecture, except this time it uses the state pattern as the main driver. And to explain this, let me first motivate what was wrong with the previous approach. The previous approach we looked at using strategy required a couple of things that are a little bit awkward. So let's go over here real quick, and I'll show you real quickly what the issue is. So if you take a look at the way this implementation works, you'll notice that any time I want to start something up, I have to pass in an enumerated type to the doRequest method. So I have to remember, if you go look at the main activity, let's go back over to activities for a second. If you go look at the main activity starts out by giving a prompt user request to the doRequest method. So prompting gets done first, and then when that finishes, the prompt user strategy turns around again and will call the download image strategy, which we kind of pass in here to the generic doRequest method. And when that guy's done, this strategy over here will go ahead and filter the image, and so on and so forth. And so we're kind of encoding things in a way where it's a little bit brittle, the order in which things are going. And we don't really know by looking at the interface. We don't know by looking at the interface of the image strategy manager the right order in which things are called. And if we call things in the wrong order, it's hard to have that caught for us automatically. So the problem here is it's a little bit too implicit, the various operations that can occur at certain times. So what we're going to do to fix this is we're going to apply the state pattern. It's another gang of 4 pattern. And the state pattern basically has you define a set of methods that correspond to the operations that are valid in a program. And then it also keeps track of which of those methods can be called in which order to be validly called. And so it's a little bit more obvious when you look at the code what's happening, and it's a little bit easier to do error checking to make sure the right things happen. So what we're going to have now is we're going to have something called image ops for image operations. And you'll see here that the onCreate method, when it gets called, starts out by prompting the user. So the first operation we're going to do is we're going to start prompting the user. So when you see that, you kind of go, okay, I think I understand that. I'm going to, I think this is going to prompt the user. Now, the interesting question is that a valid thing to do at this state? And of course, the answer is yes, because that's the very first thing to do. So we'll start prompting the user. When the result comes back, then we go ahead and call image ops do result, which is very similar to what we had before. We pass in the result code. This is basically a demultiplexing operation. We'll talk more about that in a second. Okay, so I just want to start off with this concept of the first thing we do is we start the prompt. So it's a little bit more clear what's going on here. Now let's go over to the state portion of this program. And let's start by taking a look at the image ops class. This is really the guy that does all the interesting things. So image ops has a set of methods that correspond to the valid operations that can be performed on images. And these methods are split into 2 parts. There's the start methods and the complete methods. And of course, the wild card means that we have start prompt, start download, start filter, start display. So the star is just a wild card. And the complete basically means prompt complete, download complete, filter complete, display complete. So as you can imagine, the start methods start something, and the complete methods finish what was started. And of course, in turn, they start the next thing, right? So we'll kind of see how that goes. Hopefully that's pretty clear. It's kind of easy to tell that this is an asynchronous model. Whenever you have asynchronous models, you typically have a start or invoke method, and then you have a complete or finish method to handle whatever occurred when the asynchronous operation finishes running. Now, this particular class, the image ops class, plays the role of the context in the state pattern. And what that means is all of its methods do nothing except delegate to the underlying instance of the state object, which in this case is called image ops state. And so what this means is that when you call a method on an image ops context instance, its behavior, whether the method is valid or not, and what the method does, is a function of what the state is at the time the method is called. So let's go ahead and take a look at this. It'll become a little bit more clear when I walk through it. Here we have 4 operations. We have prompt user, download image, filter image, display image. That's essentially the same as what I called strategies last time. I'm calling them operations this time. Same idea, basically. Then have something we call the result demultiplexer. And we'll take a look at what a result demultiplexer is in a second. It's just going to keep track of how to complete an operation that was started. We keep track of the state. This plays the role of the state in the state pattern. So if you were to read the state pattern, this is the state. Keep a weak reference to the activity. You'll see why we need that in a second. Here's the constructor for image ops. We stash away the activity. We start out the image ops in the prompting state. So we make the state be the prompting state at first, which means the only valid thing to do is call start prompt. Anything else you call will be an error. So we're doing some state checking. And then we go ahead and set up our demultiplexer. So the prompt user demultiplexer has a do result method that's going to call the prompt complete operation. And it also has a do error method that will print out why things failed and then wrap things up if the back button was pressed. Otherwise, we go ahead and call back up to the superclass's error method. You'll see that in a second. Download image demultiplexer basically just goes ahead and calls the download complete method. The filter image multiplexer method calls the filter complete method. This is getting kind of obvious, I think. And of course, the display image operation, that the multiplexer calls display complete. So the whole purpose of this piece of code is just to set things up so that the right complete methods get called back after an activity has finished running asynchronously. All right, so that's just kind of there to make everything go a little faster later. By the way, I think if we were programming in Java 8, we might be able to do some cool things with lambdas, perhaps here. Although that would probably take some refactoring of the code to have things be so-called functional interfaces to make that work properly. But even this is pretty straightforward what's going on. Okay, now here are all the methods in ImageOps that do the key things. Start prompt, start download, start filter, start display. Notice how all these things do is delegate to the corresponding method in the ImageOps state instance. So start prompt on ImageOps delegates to start prompt on the state object. Same thing for start download, same thing for start filter, same thing for start display. And as you'll see when we look at the state implementations, those methods are where the real intelligence goes. These methods here are simply to kind of provide an interface that is exposed to the user, and then the details of how this interface works, keeping track of the state we're in, is pushed to the state hierarchy. Prompt complete works the same way, download complete works the same way, filter complete works the same way, display complete works the same way. You could almost imagine having a tool that would auto-generate all these delegation operations because they're very straightforward. Here's the doResult method. This is the thing that works together with the result demultiplexer to get the various completion methods called or the error methods called. So this is pretty straightforward. It's almost identical to the code we had in the strategy implementation. Here's the start activity for result method. We have to put this here so we can get access to the activity so that things get sent back to the right on activity result method. And then here's a couple methods to get the current state and to set the current state. And then we have a method just to display the toast. Okay, so that's basically the context portion of the state pattern. Here then is actually the state pattern implementation. And it looks similar to the context, but it has a very important difference. Unlike the context methods, which just forwarded or delegated everything to the state hierarchy, the state hierarchy actually does the real work. And so what these things do is when these methods are going to be called in the concrete state implementations, which inherit from ImageOps state, they will do the right thing, but that depends on what state they're in. And then they will go ahead and transition to the next state, thereby making the state machine move forward. And these comments kind of explain how this all works. If you take a look at the methods here, these methods do nothing except throw illegal state exception exceptions. So every method here by default throws an illegal state exception, so that if you end up having them called in the wrong context, the wrong state, that's what will happen. You get an illegal state exception. And as you can see, that's all they do. And now take a look at how you would actually implement the state methods, or the state subclasses, the concrete states. We'll start with the easiest one, prompting state. I will try to, at some point, I'm going to make a diagram for all this stuff that shows the state machine that this is using. And once you see the state machine, it all makes complete and total sense. So the prompting state is the state that we start in, and this is an ImageOps state. And when you call start prompt in the prompting state, then that goes ahead and gets yourself an intent and starts an activity to prompt the user. Now, if you try to call start prompt in anything other than the prompting state, then of course it'll inherit the start prompt method from ImageOps state, and that'll throw an exception, which is exactly what you want to have happen because it's being called in the wrong state. So start prompt in the right state will do something, and then once it's finished, the prompt complete method gets called back, and we go ahead and we transition to the new state. So we're making it more clear explicitly in the code that we're transitioning to a new state, and then we go ahead and we start the download operation in that new state. If we didn't do the transition to the new state, of course, start download would fail because we'd be in the prompting state, and it would not have the right behavior. So you have to transition to the right state before you start calling these operations. So that's how we do the transitioning. And you'll notice that I could go even further in this and do some additional error checking to see whether or not, for example, whether start prompt had been called before prompt complete had been called. Because if start prompt hasn't been called, you shouldn't be calling prompt complete. And I just didn't do that here just because I wanted to keep it simple. But that would be another thing you could do. You could put some more error checking in. Or you could even make those be other states. You could have a, waiting for prompt to complete state. That would make the state machine bigger, which is certainly possible. But I chose not to do that because I thought this was a little cleaner. There's the make intent method, of course, that does this. Notice, by the way, that the activities are all pretty much exactly the same. Those don't really change. The downloading state method, when start download gets called, when we're in the downloading state, it goes ahead and creates an intent and kicks off a download activity. And then when that completes, then we transition explicitly into the filtering state, and then we call the start filter method. So you can see, in contrast to the previous approach, which used the strategy pattern, where it was a little bit implicit what was going on, and it was hard to do any kind of error checking. In this model, it's a lot more clear how we're transitioning through the state machine. And you can also check to make sure that if you call methods, you're in the right state. And if you're not in the right state, of course, they will blow up on you. Here is filtering state. So, of course, filtering state gets called when downloading state is finished. Start filter kicks off the activity. That's not changed at all. And when that thing is done, the filter complete method gets called back. That transitions to the displaying state, and that starts the displaying operation. And then this is getting kind of boring because it's all exactly the same. The displaying state, its start display method will go ahead and kick things off to display things. And when it's done, it transitions back to the prompting state, and we call start prompt. So that's basically the alternative implementation using the state pattern. I spent a lot of time thinking about these different solutions and rolling them around in my head, trying to decide which ones I liked and why. And at first, I was worried that the state approach was a little bit overkill. But then the more I looked at it, the more I thought it was pretty clear what was going on. And it was very explicit in the way that I named the classes and the way the control flow moved. It's very canonical. You have to be in the right state in order to do the operation. Once you finish with the operation, you transition to a new state and call a new operation. So I've actually kind of grown fond of the state pattern approach. I think it's well suited for the microservices architecture model that I'm using here. So that's kind of where my head's at this point. And of course, what you discover, the real key theme I want to convey here is that designs are rarely finished. They're just paused. You get to a point where you've decided you've reached the end of the time you had to work on them, or you're satisfied that the solution is clean enough. But inevitably, if you have more time, you can come back and think more about it and then do an even better job of refining and refactoring. Also note, by the way, that my state-based solution is actually quite similar to the strategy-based solution, and I was able to reuse lots of pieces of the code. I reused almost all the activities as is. I reused the utilities. I reused the retain fragment stuff. And the only thing I was changing was kind of how the control flow of the program was behaving. So I'd like to go ahead and take some questions. We have some people ask some questions. One of the pretty likes the state pattern approach. I like the state pattern approach too. It took me a while to really get my head around it when I was learning it, and I don't use it a whole lot. It's not a pattern I use on a regular basis, but for something like this particular design, where it was clear there were microservices that had to run in a particular order, that really motivated, in my mind, the use of the state pattern. I think that's kind of cool. Let's see, Monty says the control flow is hidden with the strategy method. And with a lot of strategies, it's hard to see what's being done. Yes, that's exactly the feeling I ended up with after I finished implementing the strategy method. If there were just a handful of strategies, it was probably tractable. Even with only the 4 we have, it was probably tractable. But if I had to explain to people how this microservices architecture actually worked, I would inevitably have drawn a state diagram, and I would have shown the nodes in the state diagram to be things like, prompting, downloading, filtering, displaying. Those would have been the nodes in the state diagram. And then the edges would have been the method calls to transition between the states. So I would have called, do request with the prompt user strategy type. And that would have been an illustration. I was transitioning from one state to another. And as I started to do that in my head, I thought, why am I going to all this trouble with the strategy pattern and so implicit? Why don't I just use the state pattern, take that state machine, and then it's really easy to explain to people because I've got these state classes, prompting state, downloading state, and so on. And I've got well-defined methods like start prompt, start download, start filter, start display. And that's really easy to draw on my state machine diagram because I just make those be the edges that come out at the right time. So it just jumped out at me that was a much cleaner way to do it. Now, if I didn't know anything about the state pattern, I probably wouldn't have gone that way. And if I didn't have the state pattern to document my design decision, then other people probably would have been really confused as to what the heck my code was doing. And even myself, as I was implementing this, I would just look at the state pattern and I would know, oh, this needs to go here, this needs to go there. So it was almost sort of paint by numbers or implement by numbers. I just looked at the pattern that told me exactly where to put everything, and my design decisions at that part of the design were very straightforward. I was just basically taking the pattern and adopting and applying it directly to my solution. So that made me feel a lot better that I was on the right track. And of course, I'm sure that there's other ways to do this as well. But I kind of like state combined with microservices. I like that way of doing things. It's not the only way to do things. It's probably not even the most common way of implementing Android applications, but I kind of like it. So another question, would this work for an enterprise solution? Well, that's a great question. So I highly recommend the next thing you do when you're done with the virtual office hours today is go out and Google around a little bit and look up microservices architecture pattern. And what I think you'll discover is that there's a lot of buzz about this. Some of it probably overkill, as always. Some of it probably interesting. And with any paradigm, you always have to take things and adapt them to your needs. So if you take a look at some of the microservices literature, they seem to imply that each microservice needs to run in its own operating system process, which of course, for something like this application would be wildly expensive and pointless, really, because Java is largely saving you from most of the silliness that would require you to use processes in, say, a C-like environment. So I think, I would take the microservices approach with a bit of a grain of salt, but the idea of breaking your complex monolithic implementation and your architecture up into a small number of microservices is certainly worth thinking about, and it seems to be the direction at which at least some people are heading. And if you read the literature, you'll see that the real driving factor and the driving motivation is actually for enterprise services. So basically, microservices become a complement to a service-oriented architecture approach. Historically, in service-oriented architecture approaches, your services were fairly coarse-grained and probably did a number of different functions. And a microservices approach is trying to split that out in smaller levels of granularity. Now, again, I am not recommending you use that for everything. I just thought it was kind of a fun approach. There may be a second part to your question, though, is would you actually use the state pattern-like model for everything? I would say no. I use the state pattern when what I'm doing is well explained with a state machine. And I think the example here of prompting, downloading, displaying, and or prompting, filtering, and displaying, that's really well explained with a a state pattern or a state machine like model. And even though there's more classes, boy, once you understand that pattern, it is so clean and so easy to add and remove the features, because they're all just completely stylized and they all work almost identically from a structural and behavioral perspective. But again, I'm not trying to say that there aren't other ways to do it. That just seemed to me to be a clean way. Also, if you don't understand the patterns, of course, something may seem harder at first than if you understand them. If I launch several async tasks to perform different operations, is it possible to join all of them, or to do something in order to know when all the operations have already finished? That's a great question. So that's one thing where the async task model doesn't lend itself to joining in quite the same way as a Java thread or the executor service, the executor completion service or completion executor service that Java supports. So the way that you typically do this, and we've actually recently implemented some examples that use a pool of async tasks to work collaboratively on a group of images we want to filter. We're doing a variant of Professor Porter's daily selfie application, where people are uploading their selfies, and then we're writing a little program that will take all the selfies, either from, say, a directory on the phone or a web service, download them or process them in place, and turn them into a MPEG movie. So it's kind of cool. So we're basically using, just for fun, we're using async tasks to do image processing on portions of the images that we're creating. And what you typically do there, if you want to join with something, you would basically have the on-post execute method, as it finishes, call back to some kind of reduce function, which takes what the results that completed have been and then merges them in with the other stuff. And then when you're all done, when the final piece has been merged into the results set or the completion set, then you would probably use another form of synchronizer, something like most likely a countdown latch or something like that, or a condition object, to signal somebody else, some other thread or some other part of the program, that it was okay for them to proceed and handle the result. So you can certainly join things with async tasks, although the joining mechanism is not identical to what you would do if you were doing threads or something else. So it's typically done through some kind of callback mechanism. Let's see. How does one learn to apply design patterns without feeling like you're forcing them? Well, literally the only way to do it is to try them over and over again. You'll see, if you want to amuse yourself, go back and watch the videos I've presented on assignment 3 over the past month, and you'll see exactly the process unfold. That's not quite in real time, because I'm only presenting things once a week or so. But if you look at the way I outlined the solution originally, it looks almost nothing at all like the solution I showed a few minutes ago with the state pattern. My initial approach used a handful of patterns, sort of. I just was trying to get it to work, and then I thought about it a little bit more, and I thought, oh, I think I'll try this approach. I'll try going with the strategy approach. So I did that, and that was okay. I was kind of happy with it, but then I thought, nah, it doesn't quite feel right. And I thought about it some more, and then went back and refactored and tried some different patterns. So it's basically a trial and error process when you're learning, and then as you get more experienced, then you'll be able to apply the patterns in a less awkward and forced way. I mean, think about anything that you've ever done in your life where you had to practice, right? So if you're a musician, or let's say you're a pianist or a guitarist, when you first learned to play, you probably spent a lot of time practicing chords and scales. And you probably sucked for a long time, right? You just couldn't get it. It hurt your fingers. It sounded bad. Your time was off. You hit the wrong notes, and you'd practice and practice and practice. And then sort of one day you woke up and you tried it, and it worked. You got the chords, you got the strumming pattern, you did the scales properly, and over a long period of time, you got more and more fluid and fluent with your ability to express yourself. And the same thing's true with dancing, martial arts, sports. And maybe the difference is a lot of the things that we learned as children. And so by the time, you're 6 years old, you're riding a bicycle, or by the time you're 10 years old, you're playing baseball or basketball or football or soccer or whatever. And you forgot that there was a lot of drill and repetition that made you good at what you're doing. Certainly is the case with martial arts, right? You're blocking and punching and kicking, and you practice that over and over and over again until it's second nature. And at first it feels really awkward and forced, but eventually it becomes second nature. So why would software design be anything different? Of course it's not. It requires practice and repeated application. And the key point I'm trying to make by showing you all these different approaches is that even people who are familiar with patterns don't always get it right the first time. But I guarantee you, now that I kind of know these little patterns that I'm using here, the next time I write an application in Android that has a similar look and feel or a similar set of design forces as the one I showed you, you can be assured I'll start with the patterns that I got to at this point rather than starting from first principles. Good question. Would the state pattern be easily integrated with the idea of an image pipeline? Yes, I think that there's quite a bit in common. In fact, if you take a look at the Android media player, if you take a look at the media player from Android, it basically has a state-like model to it. In fact, all the documentation about which methods you can call at which times are all driven by a description of the state machine. And if you read the documentation, you'll see a big state diagram. Now, I haven't gone back to look at the Android media player implementation recently to see if they actually apply the state pattern or not, but it would be interesting to see if they did or didn't. And if they do, how do they do it? And if they don't, would it be able to be cleaned up quite a bit if the state pattern were applied? That would be kind of a fun little exercise to go through. So yes, I think that image pipelines and state patterns have quite a bit in common. And in fact, again, if I had more time, I'd probably write a framework for doing a pipes and filters architecture for this solution, not just what I'm doing here, although I like what I've come up with at this point. By the way, the microservices architecture pattern is really a generalization of the old Unix pipes and filters architecture pattern, which is baked into the Unix command line processor and shell in Unix. And the same idea holds. Make each filter do one thing well, and then leave it up to the pipeline infrastructure to stream all the pieces together. And when you start playing around with Java 8 and Java Streams, which really support pipelining quite nicely with the streams model, you'll see the same idea come back again. It's amazing how these patterns are so fundamental and ubiquitous. And the technologies change. We're not programming in C. We're not programming in Unix. We're programming in Android. We're programming in Java. And yet the patterns are eternal. They come back over and over and over again in new guises. And once you understand the patterns, you can quickly understand what promising solutions there are without having to go through this long trial and error process. Which patterns have you usually used or preferred for Android applications? And so if you go back and watch any of the videos that we've covered throughout the course, you'll see all my favorite patterns come up again and again. So template methods, strategy, factory method, as gang of four patterns, a little bit of state here. You've seen facade shows up quite a bit. Those are common ones. I probably use a good half dozen gang of four patterns on a regular basis. When I'm doing concurrent programming, of course, I'm using all the POSA patterns that I helped document or that my colleagues and I worked on. And so, of course, I'm using active object or command processor or half sync, half async, et cetera, thread-specific storage. Those are the ones I typically use. So if you go back and you look at the videos, you'll see similar patterns showing up over and over again. And those are the ones I tend to gravitate towards just because I'm familiar with them. Let's see. In the first implementation, the return values were strings. So the caller activity should know the string meaning to process the result. What would be the best approach to further decouple these activities to use generic return values? Well, you can obviously pass anything you want back. You just have to have a protocol so that the sender and receiver knows what to expect. There are pros and cons with using strings. The nice thing about using strings is it's flexible. The downside with strings is it is a little bit awkward and sometimes, but you could also obviously use enumerated types of some form. Whatever you use is something you have to be able to pass back as an extra, as an extra in an intent so you can go ahead and extract it and do something with it. But that could be almost any type you want if you're willing to write the code for managing it. So play around with it, see what you like. I suspect I could keep going on and on with this if I didn't have other things to do. Question: how do you learn more about patterns? Well, take a look at the FAQ, and there's a whole section in there about patterns. So the best way to learn about patterns, of course, is to watch videos and MOOCs about patterns, and the links in the FAQ give you pointers to a bunch of places about patterns. Obviously, reading code that uses patterns is a great idea. Reading books about patterns is a great idea. But most importantly of all is writing code that uses patterns. And excuse me, what you'll find as you do that is that at first you'll probably be limited to the handful of patterns you know best, and maybe you'll stick with those because they work well. But as you read more and get more exposed to new patterns, you'll start to find ways to integrate them into your code as well. Just like the way that you learned Java or C# or C++ or any programming language, you learned about control constructs and methods and iteration and classes and inheritance and dynamic binding. You learned all these features and generics and exception handling, right? You probably didn't learn them all at once. You learned them over time. And as you got familiar with a new feature, you would try it out and see how it felt and whether you could use it. And then eventually you get comfortable applying it. So the only way I can think of to really get good at anything is to apply it repeatedly and take the time to master it. And again, there's lots of videos out there, some done by me, some done by other people that you can take a look at. Let's see. It seems to me that a good starting point for any implementation is to have small and clear implementations, both in classes and methods, that can be reused and applied inside any pattern as the design evolves. That's an excellent observation. I think to some extent that's one of the driving forces behind the microservices paradigm, trying to encourage people to think about smaller scale entities where they do one thing very well, very localized thing, and then they have requirements on their environment to get the necessary resources they need to do other stuff. So for example, if you go and look carefully at the various implementations that I've shown here in the presentations, you'll see that they make certain assumptions, right? So they typically take in a URI where the data is going to either come from or be written to. And you'll see that we use intents as kind of intents and the intent framework in Android in order to be able to provide sort of an event bus, to be able to loosely couple these components. And so, we use activities to have things running as little operations that can execute either in the foreground or the background and interact with the user or not, right? And get results back to the caller very easily with the on activity result method and stuff like that. So we're basically treating the Android component infrastructure as a framework for writing small scale services, microservices, that we can then combine and compose together in all kinds of flexible ways. And so we're kind of using the mechanisms of the Android framework, and then we're using patterns to orchestrate the order in which those mechanisms are being applied. And that's really, really cool. And I think I'm starting to really like that way of doing things. Although, of course, there's other ways of doing it. And as you play around with this, you might find ways that are even way better than what I've done. But I think you're almost always in good hands by trying to keep the pieces that you're developing relatively small, relatively general purpose, so you can reapply them and rearrange them. But also keep in mind that building reusable components is a means to an end. It's not an end in itself. You're not building reusable components to build reusable components. You're building reusable components to reuse them in sensible and effective and productive ways. So what I typically like to do is I'll go only so far when I first implement something. I'll apply patterns, I'll use generics, I'll apply my typical bag of design and implementation tricks, but I'm not going to just kill myself to come up with every possible source of variability the first time. I'm goal directed. I'm trying to solve a problem. And then as I try the next problem, as I have a new set of requirements, as I have a new problem to solve, I'll go back and I'll see what did I prematurely commit to in the design space for my first solution, and how can I refactor and re-engineer my existing code so now it covers a broader set of requirements. And I'll keep doing that over and over and over again. And eventually I'll typically end up with some really cool stuff, but I didn't have it like that when I initially started, because I don't know all the different sources of variability when I first start. I only get that as I get exposed to more things. And we're in the process of building new assignments and new applications that do new and different things. And as we do that, we're learning how to refactor the framework in all kinds of interesting new ways. Okay, well, as usual, these were excellent questions. I think we're basically done with the questions. So at this point, I think we'll wrap up. Starting next week, a week from yesterday, we'll start the next class, and that will then start talking about Android services and inter-process communication, both local inter-process communication on the same Android device, as well as inter-process communication between an Android device and something else like a web server or another Android device or whatever. And I'll be joined in that MOOC by Professor White, who will be doing some of the stuff on HTTP processing and kind of web programming. And I'll be focusing primarily on Android services and local communication. Okay, well, again, thank you all very much, and I will hopefully see you again next week.